Okay, we're going to pick up on 10.8 where we're solving logs. And a good strategy that some people do is they'll change it from log form into exponential form. So if you remember that boot method we talked about, is 6 to the second power is equal to 36. And, that is the answer. But that 6 to the second power is equal to x, and because 6 squared is the same thing as 6 times 6, then x must equal 36. What some people will do, and I'm on board with this if you want to, is to get rid of log, it's the same thing as doing 6 to that power. So I'll move that 6 in front, and that's only okay if you do that to the other side as well. So as I'm looking at the next one, again, my encouragement is more of changing it to exponential form, that 2 to the third power is equal to x plus 5. And at this point, I think you could do both steps at the same time. That 2 cubed is 8, but also subtract that 5 over to see that x has to equal 3. And you could double check that's right if you have your calculator and type in. So I'm okay with you knowing log base 2 and plugging in 3 for x, and see that you get the right answer of 3. That's what we wanted. Now, the reason why this gets even trickier is what you need to do is get the log by itself. So that's what you have to do first on this problem, where you have to add 2 over, so that's going to give me 6, and then divide that 3 over. So what I'm doing is I'm getting that log by itself. Sometimes I use the phrase you isolate the log, and after doing the work that I did, it equals 2. So at this point, I can change it to exponential form. 5 to the second power is equal to 4x plus 1, and I'm running out of room, but hopefully you can pick up on this, that 5 squared is 25, subtract the 1 over is 24, divide by 4, because it's a multiplication problem, to see that x equals 6. So hopefully I have plenty of room as I go on from here. On the next problem, though, what we have to do is combine. That is not spelled correctly, but we have to combine the logs in order to do this. I was supposed to say combining. But anyway, the thought process is that when you're subtracting with the same base, we can combine them using division. So we're looking at log base 2, got to remember to write that, of 3x plus 23 divided by x plus 1 is equal to that. I mean, I'm not changing that 3, but at this point now I can change it to exponential form. That 2 cubed needs to equal that complicated thing. And at this point, I'll go ahead and write my advice is to cross multiply. Now when you cross multiply, make sure you distribute. And if it feels like this is magic, please write down your questions and bring them to class, because this is 8 that when I cross multiply, I have to distribute it to both 8x and 1. So 8 times 1 is 8. And at this point, I think you could probably do this. Again, I didn't give you much space, but if you subtract 3x to the left side, we're at 5x. And subtract 8 to the right side, 23 minus 8 is 15. And we're left with x being 3. And you can check your work. It's just a time-consuming thing. You might even store. We've talked about the store command, 3 in for x. Can't see that. And then just type it in. Whoops. I can do it this way. Log base 2 of, now that x is 3, and then minus, and remember if you hit alpha window and hit 5, you can do that log base a little bit faster, of x plus 1, and it gave me the correct answer I wanted, which is 3. So the next one, the reason why this is a little bit tricky and why we do a lot of other stuff is when we have addition, we combine things together using multiplication. Just make sure when you multiply that you distribute. Well, I already wrote that down. I'll just write it again. That's why it becomes x squared minus 3x is equal to 1. And remember, there's an implied base in this problem of 10. So x squared minus 3x is equal to 10 to the first power, which is just 10. 10 to the first power. And now we can use our knowledge of quadratics. X squared minus 3x, and subtract 10 over, and we know factors of negative 10 that had to be negative 3. It would be negative 5 plus 2. Or you could use a quadratic formula. We're looking at x minus 5, x plus 2, and use the zero product law to see that answers could be x equals 5 or negative 2. Now here's another thing. It's been a while since we've done it. Is we can only log positive numbers. We cannot log negative 2. So that's why I've been encouraging you to check your work. If you try to log negative 2, your calculator will say error. However, if I quit out of that and I try to log 5, and then plus, I'll just do the math in my head, that 5 minus 3 is 2. Yep, I got my answer of 1 that I wanted. So 5 is the only one that works, and that other answer is what we call extraneous. Running out of room. There we go. So we can also do that type of problem with intersection points. And the theme is that they want you to set these equal to each other. So we're looking at log base 3 of x plus 25. Notice the parentheses matter. Plus 3 is equal to log base 3. Again, the parentheses matter. And what we need to do is, well, I need to get the logs on the same side. So remember, if I'm subtracting something over, I can combine them using division. So that's why this problem would be log base 3 of x plus 25 over x plus 1. Now if I subtract 3 over, that's just going to be 2. So doing some quick math, 3 to the second power, I'll jot it down over here, which is equal to 9, would be equal to that x plus 25 over x plus 1. And again, when I cross multiply, you have to distribute. 9x plus 9 is equal to x plus 25. Subtract x over, oops, meant to make an arrow there. That's 8x. Subtract 9 over, 25 minus 9 is 16. And then from there we get x equals 2. Now, you're not actually done, because if you want an intersection point, that's an x and a y coordinate. So let me change colors one more time. Kind of feel like using blue. And it doesn't matter which one you plug in for. I don't even know if these are nice answers. This one would probably be the easiest, because you're looking at log base 3 of 3. 2 plus 1 is 3. Well, log base 3 of 3 equals 1 plus 5 is 6. And feel free to use a calculator for that as well. Now this next one is finding the inverse. So if you recall, the inverse, you have to switch x and y and then solve for y. So that's what you're going to see me do. Switch x and y. And what you need, just like we did before, get the log by itself. And now that I do, I can change it to exponential form. And if you want to, you can put that in parentheses. And I'm going to take it one step further because I'm running out of space. That I also will then, after having that, subtract that 6 over. And that's the kind of answer I want. But if you remember, I also liked the inverse notation, kind of wish this author did a little bit more with it, that you might actually see the answer written this way. Now remember the next one, as I switch x and y around, I'm going to go ahead and remind you that it's implied to be a base of 10, of 2y minus 1. And again, the parentheses matter, because at this point I need to subtract 5 over, and then I can change it to log, from log form to exponential. And at this point it's actually up to you, but I would, again, you can rewrite it as inverse notation, but if I were doing this, I would just write 10 to the x minus 5 power plus 1 to add it over, and then divide everything by 2. And that's how I would do this problem. There's other correct answers though, so I would not be surprised if a few of you do a little bit different. As you recall, the next one, an x-intercept is always, always, always when y equals 0. So that's what you're going to do. Set y equal to 0 and then solve. I don't know if I really need to show all of these steps because I hope that you can do a few of them on your own, like adding 4 over, to cancel out that piece. Maybe I'll even change the colors. Because at this point, I hope you would change it from log form to exponential. So 2 to the 4th power would be equal to x minus 7. And then your last step would be to add 7 over. Although I would even take it a step further and hope that you would do 2 to the 4th power in your head. But if not, multiply it out. Use a calculator. That's 16. And then add 7 over. And you get 23 for that y-intercept. Sorry, x-intercept. And you could also check your work with a graphing calculator and plug it in. So I believe we're ready for our last couple problems here, if anybody still needs to see those. And again, it's getting you to do the same thing, except we have one more step to do. So adding, we can condense that down through multiplication. So what we're looking at is log base 2, and multiplication is commutative, so I can switch that order around. And the thought process is, if the bases are the same, then the arguments should be the same. Essentially what we're doing is we're undoing the log form by taking 2 to each power, and that's why we're simply left with 9x is equal to 45. And then at this point you can just divide that 9 over, which I hope you could do in your head, that x equals 5. And again, you could check your work by plugging 5 back in for x. And yeah, you'll notice that with a lot of these problems. Now, the difference with this next one is it's a subtraction. Right, here's a subtraction, so we can combine them using division. And again, the logs cancel out. Now, technically, what are we doing is it's a base of 10. So we're technically taking 10 to both sides. But either way you go about doing it, now you're ready to solve by cross-multiplying. Multiply that 3 over to get 15. Subtract the 1 over to get 14. And divide by 2 and you get x equals 7. Now, I will mention that you do want to check for extraneous solutions. But each one of the problems that we've done, we've gotten positive answers. You can't just rely on positive answers. You do want to double check that when you plug it in here, that 2 times 7 is a positive. Plus 1 is still positive. So that's what I mean by check for extraneous. And they even tell you in the directions here, be sure to check your answers. Because the way I would approach this next one is I don't like this 2 in front. So think about it, and then I'm just going to tell you, is you could rewrite it as an exponent. So that's the same thing as x squared and minus 2, so you can divide by 2. And just like before, if the bases are the same, they cancel each other out. So at this point, I would solve for x by multiplying that 2 over. And then when you square root both sides, you get x equals positive or negative 6. But we're checking our answer. Can x really be a negative 6? Well, we'd be logging a negative, and that's a domain error. So no, it can't be negative 6. It can only be positive 6. And again, check your answer. And that should be good. And you should be ready for the homework.